Elizabeth Carbide Die Company Incorporated currently has 4 plants. They're located in North Huntington, Pennsylvania, Lexington, North Carolina, Latrobe, Pennsylvania, and its main facility in McKeesport, Pennsylvania. Office, laboratory, and manufacturing space totals 67,000 square feet. Elizabeth Carbide has been the leading manufacturer of rotary press tooling for over 33 years. One of the principal reasons for the wide acceptance of our tooling is the high production standards we maintain. Our computerized numerical controlled equipment provides uniform tolerances on tooling of even the most intricate shapes. We're able to produce superior quality tooling that achieves longer life. To achieve the longest possible life from your tooling investment, the Elizabeth Group of Companies offer this video seminar on the care and maintenance of rotary press punches and dies. We'll also present highlights of the manufacturing process involved in producing punches and dies. In addition, we'll present the recommended equipment and methods used in repairing, polishing, cleaning, storage, and press setup of the precision tools used to manufacture your tablets. All new design concepts have their beginning in the engineering department. The addition of our computer-aided drafting, or CAD system, has greatly reduced the time required to design new tablet concepts. The computer enables the drafting person to scale up or down, rearrange lettering, or change different areas of the drawing without starting from scratch. This way, if the customer changes size requirements after receiving drawings for approval, changes can be made in the computer and a new revised drawing made up in a very short time. After the design is completed on the computer, the information is then fed to the printer, which prints the drawing in about 5 minutes. The drawing is then sent to the customer for his final approval. Some of the information required to start the manufacturing process is how much pressure is needed. Is it necessary to film coat? Will there be lettering? What kind of shape? What kind of material will be compacted? And what is the total volume of the tablet? Once approval is received from the customer on the tablet design, the programmer converts the information from the CAD system to the computer. The computer then generates perforated tapes, which are used on the CNC wire EDM machine and the CNC engraving machine to manufacture the dies and the hob. The program that's created to grind the cam, the hob, and the punches is also used to manufacture the dies. By this process, complete interchangeability of punches and dies is assured because the program required for manufacturing all components is stored for future orders. The hob is used to press the form of the tablet into the tip of the punch. This is accomplished on a hydraulic press. A program has been prepared from the approved drawing and is used to engrave the hob. The blank hob is placed in the CNC engraving machine, and the proper cutter is selected to do the engraving. After the engraving operation, the hob is then checked dimensionally to assure that it's been engraved properly. The hob is now ready to be polished. Using a tool maker's microscope to ensure that all air form of the hob, and also puts a radius on the edge of the lettering to prevent picking of the material in the pressing operation. After polishing, the hob is now heat treated to the proper hardness, then polished again to remove all heat treating discoloration. A final inspection is done on the hob to be sure that dimensions have not changed after heat treatment. The hob is then used to press the upper or lower punches. This hydraulic press has automated gates and fixtures which were designed specifically for the hobbing operation. The operator is holding a hob blank before pressing, and a hobbed punch after pressing. On the right is a punch blank that's been buffed to a high polish. This high polish helps to achieve the necessary smooth finish on the punch face during hobbing. In the center is the hob that's used to do the pressing, and on the left is the completed hobbed punch. The final hobbing procedure is very simple because all the precision alignments have been built into the specially designed nests and fixtures of the hobbing press. The hob is fastened into place at the top of the press, and the punch blank is placed into a contained fixture that will hold it in position while the hob is pressed into the blank under hydraulic pressure. These pressures can range between 50 to 200 tons, depending upon the punch tip size and the type of steel used. Hob blanks or punch blanks are machined from steel bars to close tolerances using our CNC slant bed lathe. We use only the highest grade specialty steels. Our punch steel is made to strict chemical and physical specifications and is electric furnace melted in 100,000-pound heat lots to aerospace specifications for cleanliness. This CNC lathe can be programmed to turn multiple diameters to very close tolerances, which makes each piece identical. The operator can watch every detail of this procedure performed through the display monitor. After the hobbing operation, the punches are milled to accept the key which is used to align a shape punch. The CNC mill automatically cuts the key slot in both sides of an upper punch barrel. The type being milled here is for the standard Woodruff key. We also offer the screwed-in Woodruff key and the long rectangular European type key. After the keying operation, the tip of a shape punch is machined to near finished size on our CNC mill. The precision accuracy of the CNC mill allows for a minimum amount of finished grinding stock on the tip. This saves time and reduces the manufacturing costs. We use only the highest grade specialty steels. Our electric furnace heat treat equipment not only gives the best possible hardness and stability of the tool steel, it also leaves the punch face in the best possible condition for polishing. This CNC grinder is used for close tolerance grinding of specialty punch barrels. This machine can be programmed to grind multiple diameters and shoulders in one continuous operation. The CNC grinder will rough grind all diameters, then dress the grinding wheel, then finish grind all diameters to size. Tolerances of 1/10,000ths can be held on this machine. The introduction of the traveling wire EDM machine has revolutionized the metalworking industry. Through the use of these computer-controlled machines, dies for almost any design of tablet tooling can now be manufactured at a reasonable cost. Here we show a die blank on the right with a wire feed hole. On the left is the finished die after the CNC wire EDM process is completed. The die blank is placed in the machine and the brass wire threaded through a small starting hole in the blank die. With the computer program loaded, the machine is now ready to begin the cutting process. The machine cuts by emitting very small electrical sparks that erodes the metal away. The waste material is flushed away by the use of deionized water. The computer controls the path of the cut, the die ID size, and the surface finish that's required. The same type of cam grinder used to grind the shape of the hob is now used to grind the tip of the punch to finished size. This specialty cam grinder guarantees the precise tolerance and smooth finish needed to sustain the long life and total performance of the punches. Polishing the cup face of the punch is the final operation. Great care is taken to get the best possible shine with the least amount of distortion. Our electric furnace heat treat equipment not only gives the best possible hardness and stability of the tool steel, it also leaves the punch face in the best possible condition for polishing. Polishing punches will be described in greater detail later in the program. All punches and dies are 100% inspected before they're shipped to our customers. This is accomplished by using a variety of precise measuring instruments, which include micrometers, height indicators, and comparators. The punches are inspected for the correct tip size, barrel OD, overall length, working length, head diameter, concentricity of tip to barrel, and verification of proper punch head angles. The die cavities are checked for correct size by using a lead-type material that melts at 200 degrees Fahrenheit. The die cavity is filled with this material and allowed to cool to room temperature. The slug is then lightly tapped out of the cavity using a round rod and small hammer. Care must be taken so as not to damage the cavity walls when removing the slug. The slug is then checked for size using micrometers. The die is then checked for concentricity using a precision V block and indicator. The last operation is to check the OD and the height of the dies. After all dimensions have been verified and recorded on the shipping area. After the inspection department, the punch tips are dipped into a protective material to prevent damage to the punch faces or tip edges during the shipping process. The punches are then etched with all the information a customer requires and then placed into a heavy oil bath to protect them from rust. The punches are then placed into heavy cardboard tubes that are packed in a tri-wall cardboard shipping container. The dies are also etched with information required by the customer. They are then demagnetized, oiled and rolled in protective paper and packing material, and then placed into the shipping container. When new punches and dies are received, great care should be taken during cleaning, inspection, storage, and press setup. A steel punch that will produce hundreds of millions of tablets can be damaged as a result of careless handling. A sharp punch tip edge can be easily nicked by hitting another hard surface or another punch. If you do this, you might as well do this. The little nick or the big bang both render the tool absolutely useless. The punches should carefully be removed from their protective tubes. If they're to be cleaned right away, they should be placed in a cleaning solution with care. The protective coating on the tips can be left on so no damage can result in the cleaning process. After the punches have been degreased, they should then be placed on a flat surface so as not to allow them to roll together. Now they can be washed with alcohol and hand-dried. If the tools are not to be used right away, they should be lightly oiled and stored in suitable containers. Repeated handling of tooling with bare hands may cause rust due to the acid content of the individual. We recommend the use of rubber or surgical gloves. Most damage happens to tooling in the receiving area. Therefore, we cannot emphasize strongly enough the importance of extreme care. If the punches are to be inspected right away, place them in suitable containers and deliver them to the inspection area. There are many ways that new or existing tooling can be damaged while setting up a rotary tableting press for operation. Again, extreme care must be taken and proper procedures must be followed while setting up punches and dies on a press. As I emphasized before, an appropriate storage container should be used to protect punch tips from nicks. Nick tips can be the result of punches hitting each other in a tray or tabletop. The upper punch tips can also be damaged very easily if you're not careful while inserting into FDA-approved food-grade lubricant should be applied to the punch barrel before inserting. The best way to set tooling is one at a time. The operator should approach the punch socket slowly. Therefore, if the punch tip does come in contact with the punch socket, a nick on the tool or a burr in the socket is not created. During this procedure, haste may be the punch's worst enemy. When setting shape tooling, we recommend inserting the upper punch into the die before the die goes into the socket. This method aligns the die to the punch and also helps to hold the die square in the die bore when the die lock screw is tightened. The die should enter the die socket completely by hand. If the die won't seat by hand, the punch should be removed and a brass rod having the same diameter as the punch barrel should be used to tap the die into place. The punch should never be used to force the die into the socket. The punch can now be reinserted and checked for alignment. Not all dies will fall right into place. Therefore, care should be taken when reinserting the upper punches. If the upper punch is allowed to fall, a nick in the cup edge is likely to happen. A special die ID wrench should be used when setting the dies. The wrench allows the operator to turn the die without its removal. When punch-to-die alignment is correct, there should be little or no drag between the punch and die. Friction between these two surfaces can cause scoring in the die bore and premature wear on the punch tip. The same care should be taken when inserting the lower punches. A large capsule, such as the one shown here, have a tendency to bind in the punch socket if they're not inserted easily into the center of the punch guide. This binding not only causes nicks in the punch tip from misalignment, but also may raise burrs in the punch guide, which in turn will put scratches in the punch barrel. These scratches may also cause additional problems because they tend to pick up material which results in binding. And here you can see what can happen when proper setup procedures are not followed. Another cause of damaged punch faces are tight lower punch seals or presses which have lower punch retention devices. Has this ever happened to you? That's why we recommend taking a little extra time to loosen those retention devices. If the punch seals are tight, try turning the punch as you push. It makes entry much easier. If you're going to do this, you might as well do this. Or that. The result of the above errors in setup could look like this. This punch is permanently damaged. The major cause of tool damage occurs in the first revolution of the press. During the changeover of a press, the pressure rolls and fill adjustment cams have been moved for cleaning. If they remain in this location, tools will be damaged. The feeders have been filled with material and the press is ready to start. The operator pushes the run button.
Hey, wait, hold it! This procedure can destroy a set of tools immediately, or decrease the life by developing stress from the overload.
If the correct procedure is used, the overload system is set, and then the press is hand-turned with material in the feeder. After this procedure is followed and the tools run free, the run button can now be pushed. Extreme loads can cause microscopic cracks in the punch face. The cracks may cause punch failure immediately, or it may take several months to 1 year to become evident. The removal of tools after a product run can be another situation where punch damage can occur.
These tools are used. They're dirty. They're covered with grease and product buildup. What a mess. I think I'll take these tools out of the press as fast as I can and send them to the cleaning room. Yeah, the guys down there can take care of them.
Please remember, these punches, even though used, are still precision tools and should be treated as such. If these recommendations are followed, tooling and press life will be extended. After a lot of use, punch faces may become dull or corroded, depending on the material being tableted. Also, nicks may appear on the punch tip. Through many years of specialization in polishing and reconditioning punches, we have perfected methods that work. We'd like to demonstrate various equipment and materials used in that operation. A high-speed polishing motor, small mandrels, circular horsehair brushes, jeweler's rouge polishing compound, rubberized abrasive sticks, fine grit lapping stones, liquid solvent, fine emery cloth, soft tissue wipes, and various steel collars. Punch faces are polished using a variety of horsehair brushes. The size used depends on the particular punch to be polished. The brushes are mounted on a special mandrel and placed in a chuck on a polishing motor. Please observe the protective collar that's placed around the punch tip. This is to make sure the edge of the punch is not rolled over in the polishing operation. And please remember, excessive polishing to punch faces creates additional wear. Keep repolishing to a minimum. Excessive polishing will also reduce letter heights and will round over the edges of letters and the punch tip, which will of course affect the appearance of the finished tablet. The brush is now charged with the polishing compound. The face is then polished using moderate pressure. Notice that the operator keeps the face constantly moving. This is very important because excessive polishing in one area can over-polish the lettering and result in reducing the height of the letters. After the face has been polished, a fine grit stone is then used to rework the land area to resharpen the lands, if necessary. If a blended land is required, it should be done before polishing. A rubberized abrasive stick is used to polish the working tip area. When polishing the faces of shape tooling, the same procedure is followed. A small diameter brush is used to remove the discoloration from heat treating. After this has been removed, a larger diameter brush is then used to achieve a high polish. Note that the operator continually keeps the brush charged with polishing compound. This helps to achieve a high polish in less time. Again, as with round tooling, the punch face must be kept moving at all times. You will notice the operator dips the punch face in a container that holds a solvent-type liquid. This can be any solvent that's safe to use. The solvent helps remove the wax in the polishing compound so that the area between and in the middle of certain letters will be free of any remaining compound. A light final brushing is given to the punch face to achieve the high polish necessary. You'll notice the operator is using an eye loop to make sure that all material is removed. If you're going to do that, you might as well do this. After the punch face has been polished, the punch is inserted into a special collar and placed into the speed lathe collet. The head of the punch is then sanded using fine emery cloths to break the radius and to remove any excess grind lines. The punch barrel is then polished using the rubberized abrasive stick that was used to polish the punch tip. When polishing barrels of shape tooling with the key installed, extra care must be taken so the operator is not injured. And as I've said before, careful handling is a high priority for long tool life. In this video, we've tried to highlight the manufacturing steps involved in producing quality punches and dies. This information should give press operators, tool setup and maintenance personnel an appreciation for the time, equipment, and care involved in producing each set of punches and dies supplied by Elizabeth Carbide. We constantly strive to supply better quality tools, which will give our customers longer service. The education of plant personnel on proper care and maintenance of tooling is one of our methods of achieving longer tool life. The demonstrations presented were general methods used on average type tooling. Elizabeth Carbide encourages customers to call them for advice on any specific or unusual tool problems. The Elizabeth companies are anxious to supply all your tableting needs with Elizabeth Carbide punches and dies and Hata tableting presses. Thank you, and take care.